Hey, good evening, class. Tonight we're going to learn about arithmetic sequences. I know you guys seen this word and probably pronounce it arithmetic, but for these sequences we're going to call it arithmetic. We have three I cans for tonight. The first one is I can understand how the common difference leads to the next term of an arithmetic sequence. I can determine the explicit formula for an arithmetic sequence. And I can use the explicit formula to find missing data. Okay, those are just three I can statements. You need to pause the video and write those down. Also, you need to learn how to do this because arithmetic sequences are used to model patterns and form predictions for events based on these patterns, such as in loan payments, sales, and revenue. An arithmetic sequence is the set of numbers found by adding the same value to get from one term to the next. I want you to notice that both the word arithmetic and add start with the letter A. Okay, so that's how I keep that separate from any other sequence. Arithmetic, A, add, A. And a sequence is just a set of numbers that has a pattern. Okay, let's look at a couple examples. The first one, 1, 3, 5, 7, 10, 20, 30, and then 10, 5, 0, and negative 5. Another term you need to take note of is the common difference. For an arithmetic sequence, it is the value being added between terms and is represented by the letter D. Anytime you see D from now on, it is a common difference. Okay, an example for the first arithmetic sequence I gave you, 1, 3, 5, 7. What are you adding each time? To get from 1 to 3, you're adding 2. To get from 3 to 5, you add 2. From 5 to 7, you have to also add 2. So since that difference or that space in between numbers is the same throughout the whole sequence, it's called the common difference. Okay, so for the next one, next two, we have 10, 20, 30. Well, what we're doing there is we're actually going up by 10 each time. So our common difference would be 10. And for this last example, it's a little bit different. We're actually not adding a specific number that you may see real quick. It looks like we're going down. We're going down by 5 each time. So most people think subtract 5. But really, we're adding a negative 5, which is the same thing as subtracting 5. Now, notation. As we study sequences, we need a way of naming the terms. We're going to call it A sub 1, okay? And that's going to be written out as A, the letter, sub, S-U-B, and then the number, in this case 1, okay? A is any letter or variable that can be used, okay? We could say B sub 1, we could say C sub 1. We could go and say Y sub 1. I mean, we can use any letter we want to here, okay? Sub is just telling you that it's a little 1 in the bottom right corner, okay? So now we have A sub 1 is going to be used to represent the first term, okay? Now A sub 2 is going to be used to represent the second term, A sub 3 is going to be used to represent the third term, and so on in this manner. If we're going to be talking about the 8th term, we would also use, you guessed it, A sub 8. Okay, A sub 8. Okay, finding the common difference. To find the common difference, we must find two subsequent terms. That means one right after another, such as A sub 1 and A sub 2. Then we're going to subtract those two terms. We're going to take the second term minus the first term. Okay? Now, in this example here we're going to find D, or our common difference, for 4, 10, 16. That's our sequence. And you should notice real easy that we're going up by 6 each time. Now, sometimes it's not as easy as it seems. Okay? So let's first find A sub 1 and A sub 2. Well, A sub 2, our second term, is 10. A sub 1 is 4. So now if we take a sub 2 minus a sub 1, we get 6, or our common difference. So let's find the common difference here. 1, 4, 7, 10. Now real easy there, it's real easy to find. We're going up by 3 each time. So I wouldn't even worry about doing what you were shown on the previous page. Next up, we have 5, 11, 17, 23. Again, real easy to see. You're only going up by 6 each time. Would not worry about showing the steps. For the next one, we get 9, 5, 1, negative 3. You're going down by 4 each time, so we would call the common difference negative 4. Now, if that's not real easily seen, take the second term 5 and minus 9, and you'll get negative 4. Okay? And then finally, this sequence seems to be a little bit tricky, but you can do it if you take the second term 3 minus the first term 1/2, okay? Which gives you 2 1/2, or 2.5. 2.5. Note, you can find the common difference using any set of consecutive terms. Okay, for this sequence, let's first find the common difference using a sub 1 and a sub 2. So let's take first d equals the second term minus the first term. Well, 4 minus 10 is negative 6. Now, let's find the common difference using a sub 3 and a sub 4. A sub 3, a sub 4. So let's take a sub 4 minus a sub 3, which is negative 2. Now do remember, when you subtract a negative, you're really adding the positive, okay? So now, negative 8 plus 2 is going to be negative 6. Okay? So now, what do you notice? Well, you should notice that the common differences are the same, which should be the case. Otherwise, it would not be an arithmetic sequence. Okay? Now, to find the next term in an arithmetic sequence, we must first find the common difference, d. Okay? D. Not very nice D, but it's a D. We're going to add that common difference to the last term of the sequence, and we're going to continue adding for the specified number of terms. Okay? So now, let's look at this example. Okay? It wants us to find the first 3 terms. Okay? Now, first thing you should notice is that the common difference is 4, because we keep going up by 4 each time. Now they want us to find the next 3 terms, so add 4 to 13, and we get 17. Add 4 to 17, we get 21, and then add 4 to 21, and we get 25. So there are your next 3 terms, 17, 21, and 25. Now let's find the next 3 terms of these arithmetic sequences. I got 1, 4, 7, 10. We're adding 3 each time, so add 3 to 10 to get 13. Add 3 more, you get 16. Add 3 more, and you get 19. Here, you got 5. Go to 11, so you add 6. Add 6 more, you got 17. Add 6 more, you get 23. So add 6 more to get 29. 6 more to get 35. And then 6 more to get 41. Now here you're going down by 4 each time, so subtract 4. Subtract 4 from negative 3, you get negative 7. Subtract 4 from negative 7, you get negative 11. Subtract 4 from negative 11, you get negative 15. Now here this looks a little trickier, but remember the common difference was at 2.5, okay, or 2 1/2. So 8 plus 2.5 is 21 1/2, which is 10.5. 10.5 plus 2.5 is 13. And 13 plus 2.5 is going to be 15.5, which is 31/2. Now we're going to write the first 4 terms of an arithmetic sequence that is described. We must add the d or common difference to your first term. Continue to add that common difference to each subsequent terms. Okay, so now here's our example. Our example says to write the first 4 terms of this arithmetic sequence. Okay, well, good news is it already gave you your first term, so it's almost like cheating. You got 3. Your common difference is 7, so add 7 to 3, you get 10. Add 7 to 10, you get 17. And then add 7 to 17, and you get 24. So your first 4 terms are 3, 10, 17, and 24. Very easy stuff. Now let's find the first 3 terms of the arithmetic sequence described. Okay? So for the first one, we got a sub 1 and a common difference of 6. Okay? So our first term is 4. Add 6, we get 10. Add 6 more, we get 16. For the next example, our first term is 3. Our common difference is negative 3. So that means we're subtracting 3 each time. So 3 minus 3 is going to be 0. 0 minus 3 is negative 3. And that is your first 3 terms. Now for this one, our first term is 0.5. Our common difference is 2.3. So our first term is 0.5. Add 2.3, and we get, that's a typo there, should be 2.8. Okay, 2.8. And then add 2.3 to 2.8, and we should get 5.1. So that right there is also wrong, 5.1. Okay. All right. Now, arithmetic sequences. To find a specific term, say the 5th term, or a sub 5, you could write out all the terms. What about the 100th term, or a sub 100? Well, obviously you could write out 100 terms, but that wouldn't be very easily done, or it would take a long time. So we need to find a formula to get there directly without writing out the whole list. So for tomorrow's video, we're going to learn about the explicit formula. Okay, so just to recap, to go back to the I can statement from earlier, the first I can statement, I can understand how the common difference leads to the next term of arithmetic sequence. Hopefully, after watching this video and doing our in-class assignment tomorrow, you'll be able to check that one off. Okay. Thank you very much. You guys have a good night.